our topic is Internet search engines. The linear algebra plays a crucial role in the functioning of Internet search engines, specifically in the following areas. The first one is PageRank algorithm. This is a famous algorithm used by Google to rank web pages in research results. It's based on the concept of eigenvectors and eigenvalues, which are key topics in linear algebra. The second one is metric operations. The web can be represented as a large directed graph where each page is a node and the links are edges. The connection can be described using a agency matrix. Many operations performed on this matrix involve linear algebra. The third one is singular value decompositions. The SVD is used in research engines for dimensionality reduction and for improving each result. It helps in identifying an underlying structure of the data.
Hi, I'm Angjala with a matrix number of 165079, and today I would like to present my part of this assignment, which is algebra prerequisite from course relevant to the topic. Our topic is Internet search engine. So here are some prerequisites of this topic. The first one is matrix and matrix operation. The second one is system of linear equation. The third one is real vector space. The fourth one is inner product space. The fifth one is linear transformation, and the sixth one is diagonalization. So, the first prerequisite is matrices and matrix operation. To understand the matrices and matrix operation, we need to have a basic understanding of numbers and algebra, which is including the addition, subtraction, multiplication, and division. And then we also need to understand the concept of arrays or grid to visualize the structure of matrices and also the proficiency in arithmetic operation because this is the backbone of matrix manipulation. And then the second prerequisite is system of linear equations. Uh, to understand this, we need to know how to solve the simple linear equations and familiar with the simultaneous equations. And then we also need to understand the basic algebraic manipulations, such as the substitution and elimination methods. So these skills will help us to solve and analyze the systems of equation effectively. Next, for the third prerequisite is real vector space. To understand the real vector spaces requires we need to know the concept of vector, including their magnitude and direction. We also need to know the basic geometry like Cartesian coordinates and the ability to plot points in 2D or 3D. And then we also need to know the arithmetic operation with vectors, such as the addition and scalar multiplication. These are the foundation for working with vector spaces. And then for the fourth prerequisite is inner product space. The inner product spaces built on the vector operations and geometry. So we need to know the vector operations such as the dot products and cross products in 2D or 3D space. We also need to know the basic trigonometry, especially finding the angle between two vectors. And then we also need to know the concept of orthogonality, or we can call it perpendicularity in geometry. This plays a key role in defining the inner product. On top of that, the fifth prerequisite is linear transformation. For the linear transformation, we need to understand the functions and mappings. And also, we need to familiar with the basic matrix operations, this including the transformation like rotation and scaling. And then we also need to know the concept of dimension in geometry. This will help us in visualizing the linear mappings. And for the sixth, which is the last prerequisite, is diagonalization. So from this, we need to know how to solve the quadratic equations, including the finding roots and using the discriminants. We also need to understand the basics and eigenvalues and eigenvectors for simple cases. And we also need to have a proficiency in matrix multiplication and determinants, which this is very fundamental for diagonalization. And that's all for me. Thank you.
The implementation of linear algebra in an internet search engine is commonly used using PageRank algorithm as a practical example. First, we represent the web as a directed graph where each page is a node and each hyperlink is a directed edge. This graph can be represented using an adjacency matrix. Let's take this diagram as an example. Each bubble is a web page, and arrows from A, B, C, and D represents a link on the web page which takes user to one another. Based on the network structure, we will build an expression to express which web page is most relevant to the user search. Thus, by mapping all possible links, we can describe the link present on page A as a vector, where each row is either 1 or 0, based on whether there is a link to the corresponding page. Thus, we can conclude this in form of follows. Therefore, we can form a square matrix. Now we are going to use R to store the rank of all pages. To calculate the rank of page, we're going to use formula, where N is the total web page, A is the current page, and J is the next page. Thus, R is equal to LR. We can assume that the value of R is equally normalized. Thus, R to the power of I plus 1 is equal to LR to the power of I. Applying this expression repeatedly means that we are solving this problem iteratively. Each time we do this step and update the value of R, and eventually the value will stop changing. So, the value of R is equal to LR.